Hello everyone, in this video we are going to talk about inverse of functions. So before starting with what is inverse of function, let's try to understand what is one-to-one functions. So in one-to-one function, each x value corresponds to only one y value and each y value corresponds to only one x value. In a one-to-one function, neither the x nor the y can repeat. So in simple language, we can say that every input has a unique output, or further simplified, we can say that each output belongs to only one input. A function is one-to-one function if for elements a and b in the domain of f, a not equal to b implies that f of a is not equal to f of b. So we can also say that when f of a is equal to f of b, it implies that a is equal to b. Now, why it is so important to know or learn about one-to-one function? Because only one-to-one functions have inverses. Okay, whenever we need to find the inverse of any given function, we will get the inverse of that function only if that function is one-to-one. If the function is not one-to-one, we don't get its inverse. Okay, so because each output must come from exactly one input. Now let's check how to decide whether the given function is one-to-one or not. So let's see it with the help of one example. Decide whether f of x is equal to minus 3x plus 7 is one-to-one or not. So we want to show that f of a is equal to f of b implies that a is equal to b. So what we will do in the function f of x, we will substitute x is equal to a and x is equal to b. Okay, and we'll see that in both the cases what we get. Okay, so when we have x is equal to a, the f of a is minus 3a plus 7, and we will equate it with the f of b. So what will be the f of b? When we substitute x as b, we will get it is equal to minus 3b plus 7, and then we will solve this equation. So we will cancel out this 7 from both the sides, and we will have then minus 3a is equals to minus 3b, and then we will get a is equal to b. Therefore f is one-to-one function. Okay, so when f of a is equals to f of b, we have got a is equals to b. That's why the function f is one-to-one function. Now let's take one more example to decide whether f of x is equals to x square plus 2 is one-to-one or not. So this time what we will do, we will try to plug in the different values in the function. So for x is equal to 3, f of 3 is equals to 11, and for x is equal to minus 3, f of minus 3 is also equals to 11. So here for different inputs we are getting the same output. So for 3 and minus 3 we are getting the same output, that is 11, but here 3 is not equal to minus 3, but we get the same output for different values of the x here. This means the function is not one-to-one. Now there is one more test to identify whether the given function is one-to-one or not, and that test is called as horizontal line test. So in horizontal line test, if the horizontal line intersects the graph of function in more than one point, then the function is not one-to-one. So if you look at the graph of this function, we can clearly say that it is passing the horizontal line test. That's why it is the one-to-one function graph, because here every output has unique input, or every input has unique output. And if you look at the second graph here, this output has two different inputs. That's why we can say that here output is repeated twice and it is not the one-to-one function graph, and this graph has failed the horizontal line test. Now let's look at the main topic of this video, that is inverse function. So what is inverse functions? So some pairs of one-to-one functions undo one another. For example, if we have f of x is equal to 8x plus 5 and g of x is equals to, inside the bracket, x minus 5 bracket closed upon 8. So then if we substitute x is equal to 10 in the function f, we get f of 10 is equal to 85, right? This is the output when we give input equals to 10 in the function f. And if we take this output 85 as input for the function g, we get output as 10. So it is clearly showing that both the functions undo one another, or they are the reverse of one another. This is true for any value of x. If you take any value of x, the same thing will happen. Therefore, f and g are called inverse of each other. Now, in more general way, what we can say, f of g of x is equals to x and g of f of x is equals to x if the functions are inverse of one another. Okay, if two functions are inverse of one another, they undo each other, and this way we can say that f of g of x should be equal to x and g of f of x should be equals to x, then only the functions are inverse of one another. So this indicates that if you apply f first and then g, you get back the x, and if you apply g first and then f, you are also gonna get the x only. Example: decide whether g is inverse function of f. So here we have function f as f of x is equals to 2x plus 3 and function g as g of x is equals to, inside the bracket, x minus 3 bracket closed upon 2. Now to decide this, first we have to find f of g of x. So to find f of g of x, this composite function, what we will do, in the function f of x, we'll substitute x as g of x. So we will substitute x as, inside the bracket, x minus 3 bracket closed upon 2. So after substituting x as g of x in the function, we have got here 2 inside the double bracket, x minus 3 bracket closed upon 2, again bracket closed, plus 3. So after simplifying that, we have got here x minus 3 plus 3, and after doing further simplification, we got here x. So first condition is satisfied. Now step 2, what we will do, we will find the composite function g of f of x. Now to find that, what we need to do here, in the function g of x, we need to substitute x as f of x. So we need to substitute x as 2x plus 3. So after substituting x as 2x plus 3, we have got here 2x plus 3 minus 3 bracket closed upon 2, and after simplifying that, we have got here 2x upon 2, and the final answer is x. So second condition is also satisfied here. Since both f of g of x is equal to x and g of f of x is equal to x, g is the inverse of f. Now let's look at the steps that we need to follow while finding the inverse of the given function. So to find the inverse of the given function, first we need to determine whether the function is one-to-one or not. Then we need to replace f of x with the y if it is necessary, and then switch x and y. Next step is solve for y and replace y with f inverse of x. This way we can find the inverse. Now let's try to understand how to find the inverse with the help of one example. So find inverse of the function f of x is equals to 2x plus 3. Now to do that, let's follow the step number 1. Replace f of x with y. So here we will replace f of x with the y. So we have y is equals to 2x plus 3. Then next we need to switch x and y. So instead of x we will write y, and instead of y we will write x. So here we have x is equals to 2y plus 3. Then step number 3, solve for y. So we have to isolate the y. So to do that we will subtract 3 from both the sides. So we have x minus 3 is equal to 2y. Then further we have to divide by 2 on both the sides. So we have y is equals to, inside the bracket, x minus 3 bracket closed upon 2. Now the final step, replace y with f inverse of x. So we have f inverse of x is equals to, inside the bracket, x minus 3 upon bracket close upon 2. And this way we have found the inverse function, that is f inverse of x is equals to, inside the bracket, x minus 3 bracket close upon 2. So this way we can find the inverse of any given function. Thank you.